Hey there, I'm starting to make shader tutorials, so this being the very first episode, I'm just gonna explain the basics of Unity shaders. I have already opened a standard Unity project with 3D and the default scene. So I'll just start by creating the shader, and you can do that by doing right-click, create shader, or creating a normal text file with the .shader extension. It doesn't really matter what shader we choose, it's all the same kind of file but with different stuff pre-written in them. So I'm just gonna call it basic. And for understanding, I'm just gonna delete everything and write a new shader from scratch. Unity's shader system, shader language thingy, is called ShaderLab. It's mainly based on HLSL, so I'm just going to explain how it works on the fly. First, we have to define the shader as a whole. So we write shader, and then we have to define where we can find the shader. And the path where we can find the shader can be defined with first a folder and more folders if you want to, and then a name of the shader itself. So I'm just gonna put this in the folder tutorial and call the shader itself 00 basic. So it's always on the top. So, and this is the shader. When you save it, we can go back to Unity, and it tells us the shader isn't supported, but that doesn't keep us from creating a new material. Also calling that basic. And now we can go into tutorial 00 basic. We see it's purple. That's because that's the default error shader. When our shader doesn't compile, it's purple. You will be seeing this color a lot. So we can just create a normal cube, reset the position so it's at the origin. We don't need the box collider, and by default it has the default material, which we don't want. We want our own material. So now we can see how it doesn't work. So the next thing, how we're gonna expand our shader, is by creating a subshader, which is with something. One shader can have several subshaders, and then Unity chooses, depending on the situation, which subshader to use. Usually we only have one subshader, so we don't have to worry about it. Then we're having a shader pass. One shader, one material, can be rendered several times on the GPU, but right now we're doing the basics, so we only need one pass, only one times rendering the thing. And because we're writing HLSL shaders, which gives us the possibility to write all the cool stuff you probably want to do. That's why we're putting all of it in a CG program. So, if we wouldn't put it in a CG program, there are other ways to do shaders and to put color on the screen, but it's way more rigid and doesn't give us the possibilities we need right now. Or, yeah, what we want later on. So the first thing we're gonna do is import some stuff Unity just provides for us, and that's the Unity CG include file, which allows us to call some methods that the Unity people wrote for us and will make some stuff easier for us. So the first thing we're gonna do is define a vertex shader. And the vertex shader defines where the vertex lie, where the GPU can find them and render them. And after that, it'll go in the fragment shader. Fragment. The fragment shader, also called pixel shader sometimes, is the shader which defines the color of the object. So first we can write the vertex shader, which we defined up here in line 7 as being called vert. So, and the vertex shader has to define where the object is on the screen. It doesn't matter where the object is in the world. All that matters at the end of the vertex shader is where the object lies on the screen. But we don't even know our object because it's a cube somewhere. Where's the cube? So we can get the data where it lies via the AppData base. AppData base is another thing that's defined in the Unity CG class. It's a struct, but right now we don't have to worry about it. We'll see it later again. And that can just be the vertex input. And then the vertex has to also return the information somehow. And we can best do that via another struct, which isn't predefined for us, so we have to define one. Struct. And that's the vertex to fragment struct, because it goes out of the vertex shader and will later go into the fragment shader. And the only thing that's really interesting for us right now is the position of the edges, of the corners. When we go back into Unity and change to the shaded model, we can see the model is made out of many triangles, and the triangles are made out of the corners of the triangles. So those corners are called vertex. So in the vertex shader we have to define how we get those corners. And those corners in object space, so the corners relative to the position, relative to this gizmo we can see right here, that's called the object space vertex, and we can just get them through the AppData base struct. And we can write them into vertex to fragment struct as a float 4, because it's a 4-dimensional vector. X, Y, Z are the normal coordinates we know. W isn't important right now. We just usually fill it with a 1, which implies that it's a position. So it's the position, and now we also have to tell Unity, hey, that's the position, and we write SV position. We use the SV part when it's about world space. Yep, no, never mind. We use the SV part when it's in clip space, so when it's on the screen position, and in the AppData base it's defined as position without SV. That means it's in normal space, in object space in that case. So after having defined the struct, we can just say, first we have to define a new vertex input, a new vertex output, which is of the type vertex to fragment. So this is the output, and in HLSL we can just write the type and then the name, and that's it. It's defined. We don't have to use new or something like that, which we would have to use in another language. For example, C#. After having that defined, we can say output dot position, because we call it position up here, and just write vertex input dot vertex in there, because in AppData base the position is called vertex. And after that we can just return the output. And after we define the vertex shader, we can also define the fragment shader. Oh, we're calling it a frag. And we have to also tell the fragment shader what it returns, and it will return a color. Up here we used float 4 as a 4-dimensional position, and right here as a color, we are also using a 4-dimensional color because we have red, green, blue, and the alpha channel. But we're not using float because float is pretty precise, and with colors we can get a little bit more imprecise. So we're using fixed 4. Fixed 4 is a data type which goes from -2 to +2 and goes in steps of 1 divided by 256. Also we have to define what the return value of fragment is, and in this case it's the target, which means it's the screen color. This is the screen position, this is the screen color, and when Unity has all of this information, it can just render it. And here we're also sorry. Here we also have to define the color, and we're just going to say it's fixed 4 because that's the return value, and we can say we want a dark red, so we can go 0.7, 0, 0, and 1. So the values always go from 0 to 1. So 0.5 is about 50% red, and no green, no blue, and because it's opaque, it's always completely visible. And alpha doesn't really matter, but I like putting a 1 there just to show that it's opaque. And when we go back into Unity, we see it is red, but it's also in the middle of our screen. The reason for that is that we just used the position from the vertex and just copied it onto the screen and said, yeah, it's on the screen, render it. Which is not what we really want, because we first have to convert it from the object space, so the space relative to this gizmo, to the view space, to the space in which we can render it on the screen. We can do that pretty simply by using Unity object clippos, which just casts this thing from the position in the object space where it comes from to the clip space where we actually want it. So when we go now, we can see the cube in the center, and it also respects the gizmo and follows it. So yeah, this is the basics of Unity shaders. I know it's pretty hefty, so if you don't understand anything, then please just ask. I'm willing to help you, and with a little bit of luck, there will be more tutorials. Bye!